Try the next heading, mass defect. Okay. Atom, in between atom we have neutrons will be there and we have protons will be there. Correct. So in neutron mass plus proton mass. Okay. Suppose I am assuming Mn is the mass of neutron, Mp is the mass of proton. There are n number of neutron and p number of proton. So what is the mass of the nucleus? N into Mn plus p into Mp. This is called rest mass. Rest mass. And this is the mass we have calculated via an equation. So this we got and rest mass. But practically there are some experimental methods. There are some methods will be there to measure the mass of the nucleus. Normally we'll say experimental method in your case. Okay, there are different systems will be there to measure the mass of atom, mass of nucleus, etc. So the experimental method, this mass of the nucleus, just now I am considering as this is called rest mass, for example, rest mass, and this is through an experimental, I am putting as experimental mass. But what we have seen is like experimentally we are calculator. You can just assume like we are putting in a weighing machine and we are calculating. So this experimental weight of the nucleus is less than the mass via we have calculated over a rest mass. Okay, why there is a difference? Why the difference is happening? Because here n number of neutrons, p number of protons. One neutron mass this much, one proton mass this much. So if you are adding all this, we'll get a mass, and this mass should match with your experimental mass. But experimental mass, it is less mass. Why it is happening? It should not happen, right? Last class I told for diode you are drawing characteristics. So whatever you are drawing similar to whatever you are learning. Correct? Else you will make it as correct. This is what I told at the last class. The same way, why this is not correct will be here. Experimental mass and rest mass is why it's not same. That is a reason will be there. That difference in mass. So which mass will be greater will be here? Rest mass. Mr minus experimental mass. Experimentally I calculated. I just put it in a weighing machine and I calculated. I find it is for example it is given as 9.9 kilogram for example. Okay, and here I got 10 kilogram. Then I told okay there is a 0.1 difference will be there. Where this 0.1 goes? So this 0.1 mass goes is converted into energy. So there is a difference in mass. Delta M is equal to, in this case, 10 minus 9.9 which is equal to 0.1 kilogram. This difference in mass is called mass defect. Where these mass defects are gone? Because within the nucleus you have neutron to neutron attraction or repulsion will be there, and proton to proton repulsion will be there because same charge. Neutron to proton repulsion will be there, neutron to proton like this neutron to this proton, this neutron to this proton. So there are attractive or repulsive force. Same charge means repulsive force, right? So P to P repulsive force, N to N repulsive force, N to P also repulsive force. So there are lot of different forces are existed. But because of all these repulsive forces, this is not going out of the nucleus. Where it stays, it still stays in the nucleus. So somebody is holding there. Who is holding there? That one type of energy which is holding that is called binding energy. Binding energy. So there are some energy is required within the nucleus to hold all the nucleons together. That energy is called binding energy. From where we are getting this binding energy? To get this binding energy, we are make use of this mass defect. Means there is an energy corresponding to 0.1 kilogram. So this binding energy is equal to delta M into C square. Mass is converted into energy, Einstein relation. Mass is converted into energy. In this case 0.1 kilogram and velocity is 3 into 10 power 8 meter per second the whole square. If you multiply this one, we'll get a 9 into 0.1, 0.9 into 10 power 8 joule of energy. This is a large, very high value. 16. It's a large value. Correct. So a small mass can be converted into a bigger energy level. So which means within the nucleus energy is very high. So nuclear forces are the short range forces. Short range means what? Within very smaller distance, very high forces. When the distance increases, what will happen? The energy or the force will be decreases tremendously. Not small unit, reduce. അതുകൊണ്ടാണ് ന്യൂക്ലിയർ ഫോഴ്സ് ഭയങ്കര സ്ട്രോങ് ഫോഴ്സ് ആയിരിക്കും. സ്ട്രോങ്ങസ്റ്റ് ഫോഴ്സ് ഇൻ ദ യൂണിവേഴ്സ് ഇസ് ന്യൂക്ലിയർ ഫോഴ്സ്. വീക്കസ്റ്റ് ഫോഴ്സ് ഇൻ ദ യൂണിവേഴ്സ് ഇസ് ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ്. അപ്പോൾ ന്യൂക്ലിയർ ഫോഴ്സ് ആണ് ഹയസ്റ്റ് ഫോഴ്സ് ബിക്കോസ് ഓഫ് ദ ഹയസ്റ്റ് ബൈൻഡിങ് energy. Binding energy deciding the stability of the element. More binding energy means more stable. Nalla binded on. More binding energy is more stable. Okay. Now look at your material. There is one graph will be there. Page number 141 now. I taken one page, right? Nuclear chapter 141. Page number 141. There you can see one graph. Okay. There you can see one graph. Binding energy per nucleon. So what is that graph indicate? I'll draw the same graph will be here. Binding energy per nucleon. In the books, NCERT textbook, everywhere it is there. Binding energy per nucleon. Binding energy per nucleons. And here is binding. So the graph is similar to this one. Okay, this much peak is not there. Graph is similar to this one. And here in the top, maybe as a statement, it is written as iron 56. Iron 56. Okay, that is a top point will be there. Okay, maybe in the graph it is described as a sentence, but look into the board. That is a graph I want to say. So there are lot of elements will be there. This is a graph we have plotted for all the elements in a periodic table. Binding energy per nucleon means what? One nucleon, how much energy is required? That's a binding energy per nucleon. This is something similar to our stability belt. Okay, similar to stability belt, and this is a binding energy graph. So highest binding top iron on iron 56. So iron 56 is highest binding energy per nucleon. One nucleon highest binding energy is iron. So iron is the most stable element. If you are going to right side, it become uranium 235, uranium 238. Lowest side 1H1, 1H2 like that. Elements will be there. So lowest atomic numbers elements low binding energy, which means they are not stable. Okay, but highest, this is the highest 235. 235 elements binding energy per nucleon is lesser than iron. That is also unstable. അപ്പോൾ ഈ ഒരു ഗ്രാഫിൽ റൈറ്റ് സൈഡിൽ വരുന്നതെല്ലാം they are already unstable and they are used for nuclear fission process. ഈ ലെഫ്റ്റ് സൈഡിൽ വരുന്നതാണ് ന്യൂക്ലിയർ ഫ്യൂഷൻ പ്രോസസ്സിന് യൂസ് ചെയ്യുന്നത്. Okay, lighter nucleus are they can easily fuse together and their binding energy per nucleons are very less. Less means I can easily connect it together. I can easily fuse it together. So this side il vettadalla fusion process use cheyum. This side il vettadalla fission process ne use cheyum. Highest level idukkanadalla stable aanu. It will not emit radiations. Okay, this is the concept. So what is called binding energy? Binding energy is actually an energy converted from which mass? Mass defect in the converted energy is called this binding energy. Okay. So binding energy is delta m into c square. Earlier I told to convert into energy into mega electron volt. What value we are multiplying? Minus 931.5 mega electron volt. This value is coming from this equation. For example, binding energy, if you are taking mass is 1 AMU. Okay, 1 AMU means what? 1.6 into 10 power minus 27, 3 into 10 power of 8 to the whole square. If you simplify and you want to convert into what? You want to convert it. This is in terms of binding energy will becomes in which unit called? Joule. This joule I need to convert into electron volt. For that, what should I will do? I have to multiply or divide. I have to divide. So binding energy is equal to 1.6 into 10 power minus 27, 3 into 10 power 8 the whole square divided by 1.6 into 10 power minus 19 into 10 power 6. If you do like this one, you will get the unit in mega electron volt. So the correct value means 931.5 mega electron volt while taking delta M. This is the mass, right? Delta M, mass defect. This delta M is taken as 1 AMU. Now 1 AMU, this calculations will give rise to 931.5 mega electron volt. That's what, if 1 AMU is given, to convert into mega electron volt, what we need to multiply? 931.5. Always remember this one, because based on this lot of questions will be there. So we'll write mass defect. Mass defect. Mass defect. It is a difference in mass between. It is a difference in mass between. It's a difference in mass between the rest mass of nucleons, the rest mass of nuclei, the rest mass of nuclei, and experimental mass. An experimental mass, which is called mass defect, delta M. Okay, so I'll write below, right, the next point, delta M equal to Z into atomic number into mass of proton plus. Correct? What is the neutron number? A minus Z into mass of neutron. Okay, this value minus, what value we have to do? We have to minus with this is the rest mass. This rest mass has to be subtracted from the experimental mass. Different, using different notations, but anything is fine. Delta M. Understood the mass defect? Next one, binding energy. Binding energy. Binding energy, BE. There must be an energy exist. There must be an energy exist. There must be an energy exist between nucleons within the nucleus. And this energy is called binding energy. That is derived from mass defect. That is derived from mass defect. That is derived from mass defect. We are derived from mass defect. Binding energy is equal to delta MC square. Next point. Binding energy corresponds to 1 AMU, 1 atomic mass. This can be also written as 1 U. Atomic mass for 1 AMU is equal to 931.5 mega electron volt. Very important. Next one, the force between neutron to neutron, neutron to proton is different in nucleus. NCERT point. We can draw one graph. binding energy per nucleon. Binding energy. The highest point mark Fe56. 1H1, 1H2, like that. Here uranium 235, etc. In between there are a lot of elements will be here, but most stable one is this one. Beloved, iron 56 is the most stable element. Iron 56 is the most stable element having highest binding energy per nucleon. Highest binding energy per nucleon. Highest binding energy per nucleon. Towards the right side of the graph, heavier elements like uranium 235, heavier elements like in this graph, heavier elements like uranium 235 are unstable, which are used for nuclear fission process. Next point, the lighter nuclei, 1H1, 1H2, etc. The lighter nuclei 1H1, 1H2, etc. are used for nuclear fission process. Nuclear fusion process. Okay. In the next pakka boring theory, but no way we have to write nuclear fission. Lots of notes has to nuclear fission. Nuclear fission and nuclear reactor heading. Nuclear fission and nuclear reactor. Lot of theoretical points. We'll write point by point. Okay, we'll write first point. Nuclear fission process. Nuclear fission process is the splitting of, write it. Nuclear fission process is a process splitting of heavier nuclei into smaller nuclei. Next one, fission produces large amount of energy. The nucleus produced after the fission process is called daughter nuclei. Example for a fission. No need to by heart this. Okay. So write this example. This is converted into barium 144 56 plus krypton 8936 plus 3 0 and 1. So what this indicate? Uranium-235 initially hitted with a neutron is converted into uranium-236-92. Okay, then this uranium-236-92 undergoing disintegration process and become two stable elements, barium and krypton, 144, 56, 89, 36, and it produces 3 neutrons, which means initially with 1 neutron, now it is end up with 3 neutron. These 3 neutrons can go to 6 or 9, 12, etc. So that is called a fission process. One will continue with another one. Understood? Simple one, right? Next one, energy calculation. Next point on a heading, energy calculation. Energy calculation. Energy liberated in a fission process. Energy liberated in a fission process is equal to sum of energy of daughter nuclei minus energy of parent nuclei. Energy of parent nuclei. Important are the energy of parent nuclei. Let's take an example. Just write an example. For example, just an example. An element X is converted into, for example, Y plus Z. The energy of X, for example, 2000 mega electron volt. Energy of Y may be 1240 mega electron volt. And energy of Z is 1240 mega electron volt. So, energy liberated means energy produced is equal to what? 1240 plus 1240 minus 2000. This is energy liberated in the process, in a nuclear fission or nuclear fission process. Fine. In a nuclear fission process, next point, nuclear fission process is a chain reaction. Nuclear fission process is a chain reaction. It's a chain reaction. Chain reaction means what? It will be getting continuing, correct? If 1 neutron become 3, 3 become 9, 9 become 18, like that it will go. Next point. Critical mass of the nuclear fuel. Next point on heading critical mass of the nuclear fuel and the meaning and what is called critical mass. Critical mass of the nuclear fuel. Below, right? The newly created neutrons are move with a speed in bracket, right, approximately 7% of the light speed. Approximately 7% of the light speed. These nuclei can produce a nuclear fission process on its parent nuclei on its parent nuclei having sufficient mass to produce the subsequent nuclear fission. Next one, nuclear reactor. The components of nuclear reactor. Write a subheading, the components of a nuclear reactor. Theory only, nothing, no complexity. The components of a nuclear reactor. Nuclear reactor la nariya items irukkum. What are the things, sir? 10th class, right? Physics, sir. Nuclear reactor, what are the things? Nuclear fuel, moderator, control rods, similar. So right, fuel, nuclear fuel. Nuclear reactor and the components. Nuclear fuel, example uranium-235. First one, nuclear fuel. Nuclear fuel, example uranium-235. Okay, next component is moderator. The theory is area questions it's very less. Moderator. Moderator is used to slow down neutrons released from the fission process. To slow down the neutron produced in the fission process so that they can continue with fission process. So that they can continue with fission process. Okay. Normally, moderator use in the elements. What are the things? Water, heavy water, then graphite. So right, water. Examples: water, heavy water, graphite are used as the moderator. Have you seen any atomic research center in your life?
No, sir.
No. Baba Atomic Research Center, you heard?
No, sir.
Not here, Bark, correct. Baba Atomic Research Center, Bark, Bombay. Okay, there is one nuclear plant is called Apsara. Okay, Apsara. That's called Apsara. So there they are using water as the moderator because it's a freely cost-wise. Heavy water is also there. Graphite is costly, but these things we can use. Okay, but you cannot enter there. Okay, next point. Control rods. School no college nalla anganga tour pogumbodhu inga edathukkellam pona appo useful ആണ്. Control rods. Control rods. Neutrons absorbing materials. ഇനി അടുത്ത ദീപാവലിക്ക് പാർക്ക് പോയിട്ട് വാങ്ങേ. ഓക്കെ, ന്യൂട്രോൺസ് അബ്സോർബിങ് materials. This control rods means neutrons absorbing material. Neutron, that adhigamayirikana neutrons ne this control rods will attract because we need sufficient number of neutrons, not very larger number. If in case one neutron become 3, if you are getting 6 means 6 is not required. It is unnecessary things. So a 3 ne absorb it. That is the purpose of controlling rods. So below right, these are inserted or withdrawn from the nuclear reactor plant from time to time to control the rate of reaction. Who is doing that? Which machine? Okay, it's doing by automated way. This will be doing. We have a methods to know how many neutrons are produced. Okay, how many neutrons are produced depends upon when it is crosses certain limits. What will happen? This control loads will be getting inserted, many neutrons will be absorbed, then it is coming out of the nuclear reactor. Mostly in the latest cars, and you have seen, like, if you are not putting the seat belt, it will make some sound. Okay, key, one sound will be there. Is it always a sound? No. When your speed will be crosses 20 km/h, it starts to make noise. So similarly here also we have a sensors to know the neutrons numbers are very high. If it is very high, this control loads will be inserted. When it is low, it is not coming to the picture. Okay, so below right. A temperature sensor controls the insertion of the temperature sensor controls the insertion of the what? Control rods. Example for rods: cadmium, boron, cadmium and boron are the examples. Next one, coolant. A fluid which is circulating through the core so as to absorb the heat and transfer it into a boiling water which is converted into steam. This will rotate the turbines and produce electricity. So example for a coolant: water, which produces electricity. Example for coolant: water, liquid sodium, heavy water, air carbon dioxide. Bike, car, we are also using coolant, right? What is a coolant will be there? Normally if you go to shops and if you buy for a coolant, if our radiator is very hot, we'll buy a coolant or a bottle. So what is a coolant will be there? There we are using, we can also use water, but water is efficient coolant. What is that? That's the second one, liquid sodium. It's a salty taste. Okay, never taste it. Nothing will happen, just a water with the sodium. Okay, sodium chloride. Next one, containment. Next part, containment. Everybody home at least have one vehicle, right? Two-wheeler, line of four-wheeler. So definitely you should know minimum mechanism, even though if you are not running. Containment. A meter thick or 1 meter thick concrete and steel structure. A meter thick concrete and steel structures to prevent radiation. That lead in the concrete structure, it will be falsely round. Okay. Normally, just for information, nothing else. Overall in the world, 20-25% of electricity are produced from nuclear reactor. Now we told, right, turbines are running and electricities are produced. In India still now we are not using such mechanism. So far only very few percentage electricities are coming down, but all others country, European country, US, UK area countries, they are producing electricity mainly because of nuclear fission process. Cost kammi, that's the main advantage, but risk adhigam. Okay, something will happen means it's become another Hiroshima Nagasaki. Okay, that's the danger zone. But that's safety measures. That's the implementation cost. First, the cost is very high. Once it is structured, once it is become implemented, this nuclear reactors are once it is implemented, then it will run for lifelong. Okay, maintenance wise andamari wise allame maintenance will be there, but like normal water illana dam irukkunna water we are producing electricity, right? Turbines are running with the help of waters, so there we are getting electricity, but cost will be very high. Okay, ഒരു 5 years മുന്നാടി ഇരിക്കുന്ന EB bill അല്ല ഇപ്പോൾ വരുന്നത്, കറക്റ്റ്. It will be different, right? So cost will be high, but power consumption now many things are moving to solar panels. Okay, why? Modi is increasing petrol price every day. Correct? Every day the petrol prices are going high. Okay, 90, 91, 92, like that is coming. So fuel efficiency. Now vehicles are moving to electrical vehicles. Okay, electrical vehicles ellame EV cars aanu, electrical cars aanu. Two wheelers also migrating, lot of two wheelers are available, right? Electricity, morning if you plug, morning you can go anywhere with 400 to 300 kilometers in one charge. Okay, petrol stations are going to replace with the charging stations. If a mobile charge within 15 to 20 minutes of fast charging, it will get fully charged. You can go to 400 to 300 kilometers in one shot. Okay, so one side is, other side is cost is very high, this side is cost is very less. Further we can reduce the cost by using the solar panels. That's what everybody is doing. Even car ceiling where solar panel. So when car is running, it's getting, we don't want to go to stations. That's a trend. Technology is moving, right? Other side fuel cost is cost adhikam. Similarly we are producing electricity from water, that is also cost will be higher. So fission process why electricity produced, cost is very less. Okay, more technological things, more things we can come into make it possible, because we need lot of current. Earlier days trains are running on coal, now trains are running on electricity. Metro island, non-metro stations island, everything is running on electricity. It's a very high volt, 400 kV lines. Okay, once we touch upon, next moment we will never remember that, that much powerful. So that much electricity is required. Electricity. So how we can provide this much electricity? Somewhere only in the presence of water only. Correct? No other way. If water is stopped, means electricity will stop. So both are very correlated, very connected. So we cannot lifelong will be depends for a water to produce electricity, because electricity use cases are day by day it is increasing. Okay, other use cases are, because a lot of electrical equipments will be there, at least in your kitchen, right? Many things are running. Especially so our home full lot of electrical equipments, correct? 5 years lot of equipments, anything which is required electricity. And technologies new technologies, but India still in 15 years back not yet implemented these things. That has to implement, that has to come. And risk unde, of course it is risk unde. Our risk ella vechittu we have to implement. Why government is going stepping back means because of the heavy population. Okay, high population aanu. So something will be happen means it will affect a group of large life will affect. So that's why it's not going to producing electricity from nuclear fission process. Understood? So write the next heading, nuclear fusion. Nuclear fusion process. A process in which two lighter nuclei combine to form a heavier nucleus, along with simultaneous release of energy, is called nuclear fusion process. Example, 1H1 plus 1H1, two lighter nucleus to form 1H2 plus 1 beta plus some 0.42 mega electron volt of energy. Nuclear fusions are normally happening in the sun, nearer to sun. Many elements are recommended because it requires high temperature. By the next point, to happen nuclear fusion, high temperatures are required. High temperatures are required. Why we need too high temperature? Because in the high temperature it will be melting and joining up. No. It's not like that, because there is a repulsive force will be there between proton to proton, proton to neutron. To overcome the repulsive forces, nuclear forces are the highest short range forces. So to overcome that force, that much energy is needed. That energy is given through heat energy. Okay, so below, right, to overcome the binding energy between proton to proton, proton to neutron, binding energy per proton to proton, proton to neutron. To overcome that energy, high temperature is required. High temperature is required. Nuclear forces are the short range forces. A heavier nucleus can forms to the fusion process? No, only the lighter nuclei can form the fusion processes. So below, right, binding energy per nucleon, delta Be is equal to delta mc square is applicable to nuclear fusion reactions too. Next one, nuclear fusion processes are normally happening nearer to sun. To fuse lighter nuclei at a higher temperature. To fuse lighter nuclei at higher temperature. Fuse lighter nuclei at a higher temperature. Very small theoretical things will be there, nothing else. Now can you open the material also? Below write one note. Let TA and TB, let TA and TB are the average life of two daughter nuclei, two daughter nuclei of a substance X, then the average time or mean time or average life, average time, mean time of the substance capital T is equal to TA TB divided by TA plus TB. TA TB numerator T suffix A. Capital T is equal to TA TB divided by TA plus TB. Okay, then the theory is over. Now we have to do questions. Have some set of questions. One 3 lithium 7, mass of a lithium 73, nucleus is 0.042 U. U means what? AMU, atomic mass unit, less than the sum of masses of all its nucleons. One copy I placed there. So mass of the nucleus is 0.042, less than the sum of the masses of all nucleons. So this means that what? Delta M, mass defect delta M is equal to 0.042 atomic mass unit AMU. Binding energy per nucleon will be, so delta M is given. Question number 1, delta M equal to 0.042. Okay, this is U, it is equal to 0.042 AMU. Now I need to convert into mega electron volt, because units are in mega electron volt. I need to convert it into, what is 1 AMU is how much mega electron volt? 931.5. In entrance you can remove 0.5, you can just write mega electron volt to make the calculation easier. That's all. Acceleration due to gravity 9.8 will taken as 10, right? Same way 0.5 you can remove, you can take it like this to make the calculation easier, nothing else. If you put 0.5 you will get more accurate answer, that's all. So here corresponding value is 0.042 into 931 mega electron volt. How much this will come? Close equal to 42. Can 1000 which multiply that you will get 42. 931 means 41.8 something will come. So I am writing approximately 42. Approximately 42 mega electron volt. Approximately. If it is 1000 means you will get 42, right? So this is 41 point something will come. So 42 mega electron volt. This is the binding energy. But question is what? What is question? Question is binding energy per nucleons. So how many nucleons will be there? 7. So 7 nucleons will have how much is the total binding energy? 42 mega electron volt is the total binding energy for all the nucleons. So for binding energy per nucleons means one nucleon the binding energy is how much? 42 divided by 7, 6 mega electron volt. So option is equal to 5.6 mega electron volt. Why we got 5.6? I told here we have approximate, right? 41 point something, we have taken 42. So we got 6 mega electron volt, which is more or less equal to 5.6 mega electron volt. And even approximated, so here also we have to approximate. So 42 total. So per nucleon will be 5.6 mega electron volt. Question number 2. In a nuclear decay given below, X, Z and A, Z plus 1, Y A, Z minus 1, B A minus 4, Z minus 1, B A minus 4. Okay, the particles emitted in the sequence are, first atomic number increases by 1. So what is it indicate? It is a beta particles. Okay, second one, atomic number Z plus 1 and Z minus 1 so what will be there? Minus 2 decrement mass number also decreases by 4, so it is an alpha particle. Third time is what? Atomic number and mass numbers are unchanged, so it become a gamma particles. So beta, alpha, gamma. Answer is option D. Option D is the right answer. Option D. Third question. If the nuclear radius of aluminium 27 Al27 is how much? The radius 3.6 Fermi. Okay. The approximate nuclear radius of carbon 64 R is how much? Copper. Copper. Carbon 64 varadile. Copper 64 radius is how much? For aluminium cases, what is the relation? R is proportional or R equal to R naught raised to A raised to 1 by 3. So this value is given 3.6. Okay. For aluminium, R0 into atomic number is how much? 27. So 27 raised to 1 by 3. This is equal to R0 into 3. Equation number 1. Second equation, I need to find it for copper, and copper is R is equal to R0 into 64 raised to 1 by 3. 4, 4, 16, 64. So R0 into 3. Equation number 2. That equation. We need to find out R. 4. R0 into 4. 16, 64. So now equation number 1 divided with equation number 2 will get 3.6 divided by R equal to R0 cancel 3 by 4. R equal to 4 into 3.6 divided by 3. 4.8. 4.8 4.8 4.8 Fermi meter. F. We'll move to the fourth question. Fourth one. Which of the following statements is true for a nuclear force? They obey inverse square law of distance. They obey inverse third law of distance. They are short range forces. They are equal in strength to electromagnetic force. They are short range forces. Fourth C. Fifth. A radioactive sample has its disintegration rate 5,000 disintegrations per minute. After 5 minutes, the rate is 1250 disintegrations per minute. Then the decay constants per minute will be. A radioactive sample at any instant has its disintegrations rate 5,000 disintegrations per minute. After 5 minutes, the rate is 1250. Then the decay constant per minute. Solve it. How to solve it? What is 5,000? A radioactive sample at any instant is 5,000 disintegrations per second. So I'm assuming initially I have how much? 5,000. Then after 5 minutes, 5 minutes become 5,000 and then it become 2,500. Okay, it will take some time. Okay, and keep it as it's an half-life. From T 2500 to 1250, it is taken another half-life. Correct? So it is become 2 half-life is how much? 5 minutes. 5 minutes. So 1 half-life will be equal to 5 by 2, which is 2.5 minutes. What they are asking? Lambda, decay constant lambda. Lambda is equal to 0.693 divided by half-life. 0.693 divided by 2.5, 5 by 2 or 2.5, anything, it's fine. That is the answer. How much coming? Option A, 0.4 log 2. Log 2 is 0.693. Log 2. Natural logarithm of 2 equal to 0.693. So 1 divided by 2.5 is how much? 0.4. So 1 divided by 2.5 into 0.693, which is equal to 0.4 into natural logarithm of 2. Log 2 the value natural logarithm, or this can be written as 0.4 log to the base e of 2. That is the same one. Sixth one. Radioactivity of a sample is R1 at a time T1. R2 is T2 at a time N2. If the half-life of the specimen is T, then the number of atoms that have disintegrated in the time T1 minus T2 is proportional to. What is the rate of concentrations? R1 is equal to lambda times of N1, first number. For second cases, R2 is equal to lambda into N2. What is the question is asking? Number of atoms that have disintegrated in time. Okay, so number of atom disintegrated. What is the time? T1 minus T2 is equal to N1 minus N2. Correct? This is correct or not? Initially N1, then after some time it became N2. So number of atoms disintegrated, lost in between these two stages is N1 minus N2. What is N1 minus N2 from this equation? R1 minus, or I can say N1 is R1 by lambda minus R2 divided by lambda. R1 minus R2 divided by lambda. Then we have to connect with half-life, because capital T is given. Capital T is given of the half-life. How to connect with the half-life? So 1 by lambda is what? I can say R1 minus R2 divided by 0.693 by half-life is what they are given? Capital T. So I can written as R1 minus R2 into capital T whole divided by 0.693. So I can say this N1 minus N2 is proportional to what? R1 minus R2 into T. R1 minus R2 into T. Question is they are asking, they are proportional to. Correct equation is R1 minus R2 divided by into T divided by 0.693. This is tricky. Number of atoms disintegrated. T1 minus T2 means N1 minus N2. N is a number. And a difference on a number of atoms which are disintegrated, which are lost. This is tricky. The balance will automatically come. And this tricky, that's all. practice, yeah, that's all. Through practice only things will. One chapter on 250 to 300 questions arranged. Okay. So R1 minus R2 into 2 option is D for 6th question. 7th one. In the reaction 1H2, 1H3, 2He4011. The binding energy of 1H2, 1H3 and 2He4 are ABC in mega electron volt respectively. Then the energy released in the process. The energy released, energy liberated, energy released is equal to what? Sum of energy of daughter nuclei minus parent nuclei energy. So what is the sum of daughter nucleus is how much? Only C. So C minus of parent nucleus A plus B. So C minus of A plus B, which is equal to C minus A minus B. Answer is C. What is the difference is that for the daughter nuclei energy will be higher. Why? Because for everything there will be potential energy plus kinetic energy. The parent nucleus are not moving. Adinte energy it's less. But the daughter nucleus are moving with a kinetic energy of P square by 2m. Because of the additional kinetic energy gained by the daughter nuclei, the energy of the daughter nuclei is higher than the parent nuclei. Reactant is equal to product, but energy of reactant is not greater than energy of product if energy is going out from the daughter nuclei. Energy of the product, in this case nuclear fission process, energy of the product or the daughter nuclei is higher than the parent nuclei because this is gaining extra additional kinetic energy of P square by 2m. 8th question. If M, A, Z, MP, Mn denote the masses of the nucleus for the element, Z, Xi, proton, neutron respectively in units of 1U, 1 atomic unit 931.5 mega electron volt per C square. And binding energy represent its bonding energy in mega electron volt. Which of the following equation is correct? So what is the definition of binding energy? Binding energy means we told rest mass divided by experimental mass. What is the rest mass? Rest mass is M, the calculated mass. What is it called? ZMP calculator. Rest mass means we are calculator. Z into MP plus A minus Z, neutron number into Mn. This is called rest mass. Minus experimental mass. Experimental mass means M, A, Z. This is called binding energy. This is the mass difference delta M into C square. Binding energy per nucleus. But what we need to find out? M is. This is rest mass. This is calculated mass. Calculated mass. Calculated mass. This is experimental mass. Experimental. So experimental mass they are asking. So M of A, Z equal to binding energy per nucleon square. What will come? This is the minus here. So opposite, right? ZMP plus A minus Z into Mn minus binding energy per C square. Option A. Option A. Ninth. What happened in Dubadi? Okay, ninth. Ninth. How does the binding energy per nucleon vary with the increase in number of nucleons? Binding energy per nucleon varies with the increasing number of nucleons. How the structure of graph? First increases and then decreases in mass number wise. This is a graph, right? Increases and then decreases. Okay, number of nucleons. Here we can write number of nucleons, or in some textbook you can say atomic number. Okay, this is a graph for binding energy per A. Per A means per nucleon. Mass number which divided the per nucleon. So first increases, then decreases. What's the top value? Iron 86 or 56. Okay. 10th one. Energy spectrum of beta particle number n of E as a function of beta energy is emitted from a radioactive material is. See, already we have drawn in the notebook, right? Energy spectrum of beta particles. 10th C. 11th one. 10th C we have already drawn in the notebook, that parabolic kind of model. 11. A radioactive nucleus undergoes a series of decay according to the scheme A1, A2, A3, A4, A4. If the mass number and atomic number of A are 180 and 72 respectively, then A emitted A1, which what it is emitting? A means alpha. Then A2, then A3, then A4. A1 to A2 is become beta, then become alpha, then gamma. Initial number is 72 and 180. So alpha emitted become 176 and 70. Beta emitted become 71 plus 176. Alpha emitted becomes 69, 172. Gamma emitted becomes 172, 69. Something is there? Option A. Option A is the answer for the 11th one. When alpha emitted mass number decreases by 2, atomic number decreases by 4. When beta decay, atomic number increases by 1. It is actually beta minus decay. Beta plus decay decreases. Okay. Fine. So far clear, huh? Back side. 12th. Activity of a radioactive sample is measured as 9750 counts per minute at t is equal to 0. 975 count per minute at t is equal to 5 minutes. Decay constants approximately. Activity in the formula R equal to R0 into e power minus lambda t. Correct? What is the R value now? 975. R0 value 9750. E power minus lambda. Time is how much? 5 minutes. Lambda value and root. 975 divided by 9750 is equal to e power minus 5 lambda. 1 by 10 is equal to e power minus 5 lambda. So logarithm of 1 by 10 is equal to 5 lambda. Log 1 minus log 10. Log 1 minus log 10 is equal to 5 lambda. What 5 lambda? Minus 5 lambda. Okay. this log which is having base e. So I am writing as log base e 1 minus log base e. This natural logarithm can be written in this way, is equal to minus 5 lambda. Natural logarithm has to convert it into base 10, provided you have to multiply with 2.303 log base 10 of 1 minus 2.303 log 10 of base 10 is equal to minus 5 lambda. This value is 0 minus of 2.303 into 1 is equal to minus 5 lambda. Lambda equal to 2.303 divided by 5. Natural logarithm to base e conversion. Hope you know. I don't know. This natural logarithm, ഇതിന്റെ മീനിങ് കിട്ടുന്ന ഇത് ബേസ് ഇ ആണ്, എക്സ്പോണൻഷ്യൽ ആണ്. അതിനെ 10 ബേസിലോട്ട് കൺവേർട്ട് ചെയ്യുമ്പോൾ യു ഹാവ് ടു മൾട്ടിപ്ലൈ എക്സ്ട്രാ വിത്ത് 2.303. റിമെമ്പർ, everywhere it is used. Basic fundamental principle in mathematics. Maths is an interesting subject, right? Maths, we call it as servant of every language or every subject, because it is serving everywhere. Correct alla Praveen? Maths very interesting alla. I like it very much. പഠിക്കുന്ന മാതിരി പഠിച്ചാൽ ഭയങ്കര ഇൻട്രസ്റ്റിംഗ് ആണ്. ഫോർമുല പഠിച്ച് സബ്സ്റ്റിറ്റ്യൂട്ട് பண்ணக்கூடாது, എസ്പെഷ്യലി ഇൻ്റഗ്രേഷൻ. ഓക്കെ, okay, so let's go to 13th. Actinium 231, which means 231 actinium AC with where I lost the question, 89. Okay, emit successive 2 beta particles, 4 alpha particle, 1 beta, 1 alpha plus several gamma rays. What is the result of isotope? 2 beta. If emitting 2 beta, it become an element having X, I don't know what is that, it become 91 and become 231. How many beta? 2 beta. Then it is emitting 4 alpha. 4 alpha means atomic number decreases by 4 into 4, 16 times. So I am representing another element called Y. 16, how much will come? 231 minus 16. 230 come at 216, 215, right? 215. This 81, there are 4 alpha. So it become 83. 83. Okay. Then next element after 4 alpha, what is the further emitting? 1 beta. 1 beta is emitting, it become 84 and another element is Z and it become 215. Then what is emitting? 1 alpha. Stupid. So it become 2, 11 and 82. Then several gamma. That's all. 2, 11. Already they can understand. I know alpha. Then why they want to check it again? Correct? 211. Correct? Then 82. Oh, lead is like this, huh? PB, lead, right? 2, 11, 82. Lead. Very poisonous. Okay. Very. Fusion reactions are take place at higher temperature because kinetic energy is high enough to overcome the repulsions between nuclei. Means proton to proton, proton to neutron. So 14th answer is D. 14th answer D. 15th, if M0 is the mass of an oxygen isotope, O1718, MP, Mn are the masses of proton and neutron respectively, the nuclear binding energy of the isotope will be nuclear binding energy, rust mass minus Which one will come? Rest mass means what? Mass of the oxygen isotope. If M0 is the mass, then binding energy of the isotope will be. Actually, C where C in the reverse. Correct. C in the reverse. M8 MP plus 9 Mn minus M0 into C square. If we calculate what we'll get? We'll get a negative value. That's all. Okay. The binding energy of the, if there is no options, we can choose it as option C. So that will get an energy in a negative value. That's all. Okay. Actually, the option C should be reversed. How it should come? 8 MB plus 9 Mn minus M0 into C square should come. Then only binding energy is a positive value. Binding energy, idhe mari calculate panna negative value. Where options onnu idil ithra matching illadonda I am choosing C. Okay. 16th. 15th C. C in the reverse on answer but there are no other options which are matching most suitable to this one. 16th. Which of the following nuclear react, or in 15th question you can add one sentence. The nuclear binding energy of the isotope in magnitude. The nuclear, in 15th question you can add the nuclear binding energy of the isotope in magnitude wise. So then sign is doesn't matter. Okay. Okay. We'll go to the 16th one. Which of the following statement, which of the following reaction is not possible? Let's see. Two side lo atomic number and mass number has to be matching. Same. So which one is not matching with the given one? C. C, what is the difference? Atomic number left side 2 1. C option. 16th. 5 beryllium 11 plus 1 H1 will lead rise to 4 beryllium 9 plus 2 helium 4. This one is 13 is coming, but this one is 12 is coming. So 12 is not equal to 13. So it's not possible. 17th one. Ratio of the half-life of two elements A and B is TA by TB. Ratio of the respective decay constants are. So first we write for TA equal to 0.693 divided by lambda A, TB equal to 0.693 divided by lambda B. Question is asking what? TA by TB. So TA by TB equal to lambda B by lambda A. Lambda A by lambda B equal to TB. So answer is option A. Lambda A by lambda B is equal to TB by T. And reverse left side. 18th. Two radioactive materials X1 and X2 have decay constant 10 lambda respectively. If initially they have the same number of nuclei, then the ratio of the number of nuclei of X1 to that of X2 will be 1 by E after some time. Can you solve this up? I'll wait for you. Answer it? 1 by 9 lambda. I don't know this. Two radioactive material X1 and X2 have decay constant 10 lambda, 9 lambda. If initially they have the same number of nuclei, then the ratio, the normal formula is N equal to N0 into E power minus lambda T. So for first two material, equal to N0 into E power minus 10 lambda T, equation number 1. Second one, x2 initially same number, so it is also equal to n0 e power minus lambda t, equation number 2. 1 2 x1 divided by x2 is equal to e power minus 10 lambda t divided by e power minus lambda t. Number of nuclei x1 to that of xt will be 1 by e, so this is given as 1 by e. E is equal to e power minus 10 lambda t plus lambda t. Okay, so this is given as e power minus 1. E is equal to minus e power minus 10 lambda t plus lambda t. Both sides we can equate taking logarithm. So both side exponential can be cancelled, right? Both side exponential can be cancelled. Or if you take log, what will come? Minus 1 natural logarithm of e is equal to minus 10 lambda t plus lambda t natural logarithm of e. That is a logarithm. So minus 1 is equal to log e cancel. Minus 1 equal to t into minus 10 lambda 9 lambda. So t is equal to correct 1 by 9 lambda. This type of questions will come. Okay, in a range. Just a formula, direct form, two cases only. So we created a formula. Then we solved the formula. Which one cancelled? This cancel. Log 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 basically log x raised to n equal to n log x. N log x that's apply e factor into log e nu varum. Ivide natural log aanu basic rendu cancel. Okay. Mithun understood? 19th. In a radioactive material, the activity at a time t1 is R1 and later time t2 it is R2. Decay constant of the material is lambda. Then how to find out? R1 equal to R0 into e power minus lambda t1. R2 is equal to R0 into e power minus lambda t2. What they are asking? Lambda they are asking, right? One second. If the decay constant of the material is lambda, then okay. So I am dividing R1 divided by R2. R0 R0 cancel. E power minus lambda t1, e power minus lambda t2. So R1 divided by R2 is equal to e power minus lambda t1 plus lambda t2. R1 equal to R2 into e power lambda into t2 minus t1. Option D. 20th question. Correct relationship between average life T average and the half-life of the radioactive nucleus. C option. Okay. So what is average life? T average is equal to 1 by lambda. Correct? 1 by lambda. So what is T half-life? 0.693 divided by 1 by lambda, which means 0.693. What is 1 by lambda? T average. So T half-life is equal to 0.693 into T average. Answer is C. Able to follow me backside? Lag illalla? All are in the same page, 19. If the nuclear force between two protons, two neutrons, and between proton and neutrons are denoted as FPP, FNM, FPN respectively, then tell me what's answer? Nuclear force between proton and proton, neutron and neutron, proton and neutron, all are same or different? All different. We have written in the note one point somewhere, I don't know where. Can you check it? We have not written, huh? I think we have written, right? Somewhere I told. Section is there, huh? Somewhere we have written. One point somewhere, I don't know where it is. Somewhere we have written one point. I think so. Or I missed it? Binding energy per nucleon. Maybe then I told in the class also. Different. It's written, huh? Okay. It's different. So answer is actually D. We have written in the notebook. Somewhere one point. Proton to proton, or somewhere. I don't know where it is. Under which heading I didn't remember. Okay. Then it is unequal. Answer is 21D. This is what I told you. Please read NCERT textbook. Okay. Maybe somewhere one hint will be there. Okay. 22. So 21 answer is D. All the forces are always unequal. 22. Which one of the following correct is about fission is true? Approximate 0.1% mass is converted into energy, true or false? True. So that's answer. No other option. Only one, right? So it is correct. It's from NCERT only. Directly from NCERT sentence. Most energy of a fission is in the form of heat. No. There are daughter nucleus also there. In fission, uranium-235 is about 200 electron volt energy is released, not 200 mega electron volt. But a mega missing. That is because the statement is wrong. Okay, they're asking which statement is correct, right? Not electron volt, mega is the statement correct. Fourth one, on average 1 neutron is released per fission of uranium-235. One average average number of nucleus produced is 2.5 exactly. 2.5 number of nuclei illa 3 Okay, 2.5 average ആയിട്ട് 3 nuclei ആണ് ഒരു fission process ൽ produce ചെയ്യുന്നത്. It's not 1. That's why the fourth statement is incorrect. First statement is a correct sentence directly from NCERT. 23. If 200 mega electron volt energy is released in the fission of uranium-235 nucleus, number of fissions required per seconds to produce 1 kilowatt power will be. Power energy relation is what? P is equal to NE by T. There we want to be find out what is number of fissions per fission required per second. N has to be find out. Per second means 1 second. You have to find out the fissions required per second. Power is equal to NE by T. Calculate. power is equal to NE by T. N is in number per second, means 1 second of time. Energy is given how much? 200. So N by T has to be find out. This is 200. Energy is 200 mega electron volt. Power is in kilovolt. So power is converted into what? Kilowatt. Kilowatt in a, so 1 kilowatt means 1 into 10 power 3 watt is equal to N by T has to be find out. Number of nucleus required per seconds to produce 1 kilowatt. Energy 200 mega electron volt converted into joule, because here power is in watt, SI unit. Right side also we need SI unit. So mega electron volt in a, how to convert into joule? 10 power 6 electron volt into 1.6 into 10 power of minus 19. Then to simplify, the N by T has to find out. Nuclear forces are charged. Forces between proton and proton force is equal to the force between neutron and neutron. Coulomb force, which is equal to the force between proton. This means nuclear forces are charged. Which book? Tappu. Katala. Wrong statement. Equal. Because proton to neutron repulsive force. Why? Neutron has chargeless. F is equal to 1 by 4 pi epsilon zero Q1 Q2. Electrostatic force ulla apply pannadhula charges irukadhu. So it's not equal, it is unequal. Nariya reasons on the mass different aanu, charge different aanu. So randume ore maari illa. Correct alla, mistake on a statement. Okay. What is the answer? 3.125 into 10 power 13. 10 power 13. A, option A. N by T is equal to 3.125 into 10 power of 13. Okay, let's move to question number 23. 24. For the 23, 22 we have answer, right? This is 23. 22 answer is A. So 24. In a fission process, ratio of mass of the fission product and mass of the parent nucleus is ഒരു fission process parent nucleus ഉണ്ടായിരിക്കും, then daughter nuclei. Then we have ഒരു ആൻറ്റി ന്യൂട്രിനോയോ ന്യൂട്രിനോയോ ഇല്ലെങ്കിൽ ന്യൂട്രോണോ സംതിങ് ലിസ്റ്റ്. അപ്പോൾ സം ഓഫ് ഡോട്ടർ ന്യൂക്ലിയെ പ്ലസ് ന്യൂട്രോൺ ഈസ് ഈക്വൽ ടു പാരന്റ് ന്യൂക്ലിയസ്. ബട്ട് ഹിയർ വാട്ട് ഈസ് ഗിവൺ? മാസ് ഓഫ് ദ ഫിഷൻ പ്രൊഡക്റ്റ് മീൻസ് ദ പാരന്റ് divided mass of the fission product means daughter nuclei divided by mass of the parent nucleus is less than 1. Is less than 1, should not be greater than. Daughter nuclei kuda if you are adding neutrons anti-neutrino product ademalla subatomic elements kuda add edana rendume equal avum illana equal alla adu, so it is less than 1.
Fission products and products
fission products nu solluma adu varadhu adu aa neutron positron illana anti neutron okke fission byproducts nu sollum. Neenga physics chemistry padikala byproducts adhe mari ikkana byproduct that is yielding for the next production. 25. Radioactive element x1 x2 have the decay constant 5 lambda respectively. If initially they have the same number of nuclei, then the ratio of number of nuclei x1 to the x2 that will be 1 by e lambda after a time. This is similar to a previous question.
1 by 4 lambda.
This is similar to which question? 18th question at similar ana. Answer is
1 by 4 lambda.
All of you solved it? I'll solve it. 25th. If you are not solved it, please solve it. x1 equal to n0 into e power minus 5 lambda t. x2 equal to n0 into e power minus lambda t. x1 by x2 equal to e power minus 5 lambda t plus lambda t. x1 by x2 is given as 1 by e power minus 5 lambda t plus lambda t. So e power minus 1 equal to e power minus 4 lambda t. Minus 1 equal to minus 4 lambda t. So t equal to 1 by 4 lambda. 25th. Answer is option A. 26. Binding energy of deuteron is 2.2 mega electron volt and that of helium is 28 mega electron volt. If two deuterons are fused to form one helium, then the energy released. So deuteron means 1 H2 plus 1 H2 give raised to 2 helium 44, and this energy is how much? 28 mega electron volt. So for one deuteron, what is the energy? 2.2 mega electron volt. So these also will have 2.2 mega electron volt. Due to the fusion, some energies are released which is called Q, and that energy will be equal to energy of daughter nuclei minus energy of parent. So daughter nuclei is 28. Parent nuclei is 2.2 plus 2.2, 4.4. So 28 minus 4.4. 23.6. The last to last year question Neet. Last year la adinu munadi. One day back. Same question. 23.6, exactly the same. 27th. Consider a radioactive material of half-life. This year la online JEE online paper la question aayirunnu, the 27th one. Last session la last question. Consider a radioactive material of half-life 1 minute. If one of the nuclei is decaying now, then the next one will decay at after any time, because I don't know, because nuclear reaction is a random process, random, spontaneous, random. I don't know what's happening next. So at any time is the answer. First മൂന്ന് ഓപ്ഷൻ എടുക്കുമ്പോൾ ആ സെക്കൻഡ് തേർഡ് ഓപ്ഷൻക്ക് ഹൈ ചാൻസ് ആണ് അല്ലേ, ഒരു ടെൻഡൻസിയാണ്, അതാണോ എന്നുള്ള ഒരു തോട്ട് വരും. അതാണ്. So adana nuclear process is a random process. Now it is decaying. Next one I don't know. Random means any time. 28. Mass of alpha particle is the mass of the alpha particle is less than the sum of masses of 2 protons, new neutron, equal to the masses of 4 protons, equal to the sum of masses of 2 neutrons and 2 protons. Which one answer? For 28. അത് മാസ് ഡിഫക്റ്റ് വരുന്നതാണ് ഇയർ ആൻസറിങ്. മാസ് ഓഫ് ആൽഫ പാർട്ടിക്കിൾ കേട്ടിന മാസ് ഡിഫക്റ്റ് നോ നീഡ് ടു ടേക്കൺ ഇൻ ടു അക്കൗണ്ട്. 28 ആൻസർ ഇസ് ഡി. സിമ്പിൾ ആയിട്ട് ഫോർ 2 പ്രോട്ടോൺ 2 ന്യൂട്രോൺ എന്നുള്ള ഒരു കോൺസെപ്റ്റ് എടുക്കണം. 29th there is a mistakes in the question. ഇതില് 28th question നിൽക്കില്ല, അത് രണ്ട് രീതിയിൽ we can answer. Okay, if one student is taken binding energy concept, mass defect എടുത്തിന mass defect think பண்ணினா option A correct ആണ്. ഈ മാസ് ഡിഫക്റ്റ് ഇല്ലാமல் തിങ്ക് பண்ண, കാരണം മാസ് ഡിഫക്റ്റ് തന്നെ ഡിഫറൻസ് ഇൻ മാസ് തന്നെ, கொஞ்சம் മാസ് കമ്മിയായിരിക്കും, ലെസ് ദാൻ സം ഓഫ് മാസ് ഓഫ് 2 പ്രോട്ടോൺ ആൻഡ് 2 ന്യൂട്രോൺ. இல்லைனா அதே மாதிரி பிளைனா திங்க் பண்ணினா ஈக்குவல் டு சம் ஆஃப் மாசஸ் ஆஃப் 2 protons and 2 neutrons. இதே மாதிரி வந்துனா which one you will answer? D ആൻസർ എന്നും കറക്റ്റ് ആണ്, എ ആൻസർ എന്നും കറക്റ്റ്. ബട്ട് ഐ വിൽ സേ മോസ്റ്റ് ആക്യുറേറ്റ് ആൻസർ ഈസ് എ എന്ന് ചൊല്ലും, കാരണം ബൈൻഡിങ് എനർജി എന്നൊരു കോൺസെപ്റ്റ് ഇൻവോൾവ്ഡ് ആണ്. ഈ ഒരു തിങ് പ്രോസസ്. സോ എയും ഡിയും കറക്റ്റാണ്, ബട്ട് എ ഈസ് கொஞ்சம் കൂടെ വേണം ഒരു പ്രിഫറൻസ് കൊടുക്കാം ബിക്കോസ് ഓഫ് ദ ബൈൻഡിങ് എനർജി. ഓക്കെ ഓക്കെ, ഐ വിൽ ചൂസ് എ. സോ ബിക്കോസ് ബൈൻഡിങ് എനർജി കോൺസെപ്റ്റ് ചെയ്തിരുന്നു ഞാൻ. അപ്പോൾ ക്വസ്റ്റ്യൻ ഒരു 100% ക്ലിയർ അല്ലാന്ന് ചൊല്ലും. 29th ക്വസ്റ്റ്യനിൽ മിസ്റ്റേക്സ് ഉണ്ട്. ഡിക്കേ കോൺസ്റ്റന്റ് എന്നല്ല ഫസ്റ്റ് വേർഡ്, ആവറേജ് ലൈഫ്. The average life of a, അത് ക്വസ്റ്റ്യനിൽ മിസ്റ്റേക്ക് ഒന്നാണ്. ആവറേജ് ലൈഫ് ഓഫ് എ റേഡിയോ ആക്റ്റീവ് സബ്സ്റ്റൻസ് ഫോർ ആൽഫ ആൻഡ് ബീറ്റ എമിഷൻസ് ആർ ടി ആൽഫ ടി ബീറ്റ. T alpha T beta. If the substance emit alpha beta simultaneously, average life of the material is C. T alpha T beta divided by T alpha plus T beta. 29th C. If the end A of a wire is irradiated with alpha and the other end B is irradiated with beta rays, then ഒരു എൻഡില് ഇറേഡിയേറ്റഡ് വിത്ത് ആൽഫ മീൻസ് ദാറ്റ് ആൽഫ ഒരു വയറിൻ്റെ ഒരു എൻഡ് ആൽഫ റൈസിനെ എമിറ്റ് ചെയ്യുന്നു, വേറെ സൈഡ് ബീറ്റ റൈസിനെ എമിറ്റ് ചെയ്യുന്നു. ആൽഫ റൈസിനെ എമിറ്റ് ചെയ്യുമ്പോൾ അറ്റോമിക് നമ്പർ വിൽ ബി ഡിക്രീസസ് ബൈ 2. Atomic number decreases by 2 means it's a donor in chemistry, correct? I am giving something means my atomic number will be reduced. So donor become what charge? Positive charge. Other side beta. Beta means atomic number increases by 1. So which means gaining of electrons. So beta side become negative. So A side is positive, B side is negative. Current is flowing from higher potential to lower potential, positive to negative, which means A to B. Current will flows from A to B. 30 answer is A. 31. A radioactive nucleus of mass M emit a photon of frequency nu and the nucleus recoil energy. Recoil energy means it's nothing but the kinetic energy. So below write a note, recoil energy is equal to half m v square. Generally half m v square. Momentum is equal to, this may be a new thing, momentum mv is equal to energy by c. So m square v square equal to e square by c square. So recoil energy is equal to 1 by 2 into, I am multiplying with the m here, so m square v square, so divided with m. So what should I get? 1 by 2. What is m square by e square? E square by c square divided by m. So it is e square c square divided by 2m. E square c square divided by 2m. What is energy of a photon? Photon energy na h nu, correct? Photon, light in energy, because answer is in terms of frequency. So h square nu square c square divided by 2m. H square nu square divided by 2m. C square will come to denominator. E square by c square. 2m c square. H square nu square 2m c square. This is the recoil energy. This might be a new information to you. Yes, I have not taken recoil energy. Chance korava, but yeah, still there. Wait a minute, 1 second. Yes, tell me. 30.
A is giving electrons, sir. B is accepting electrons, sir. So current will be in opposite direction.
No. B is not accepting. A is an element which is radiating alpha. One end. B is emitting. That is not a closed circuit. The പോയിട്ട് അതിൻ്റെ വരാതെ, കാരണം ബീറ്റ ഈസ് അക്സെപ്റ്റിംഗ് 1, ആൽഫ ഈസ് ഗിവിംഗ് 2. That is different, right? It's not like accepting and giving from one side to another side. It's different. So 31 answer B. 32. 2019 NEET question 32. Radioactive element decays in the form of a stable nuclei. The rate of decay is reactant is proportional to n with respect to t graph. 32C, n with respect to t graph. n with respect to t graph. ഇതിന്റെ log graph ആയിരുന്നു this year JEE main question. ഇതിന്റെ log graph, right? We have drawn the logarithm of graph. The nucleus of mass m plus delta m is at rest and decays into two daughter nuclei of masses m by 2, each with a speed of light c. Speed of the daughter nuclei will be, how to find out the speed of the daughter nuclei? Nucleus of mass m plus delta m is rest and decays into two daughter nuclei. I am applying energy conservation. Energy conservation. First, parent nuclei is at rest, so it's not moving. Okay, so it's not moving. So the daughter nuclei which is at moving, half into m by 2 v square plus half into m by 2 v square. രണ്ട് ഡോട്ടർ ന്യൂക്ലിയ, ഇതിന്റെ സം. ഓക്കെ, വാട്ട് ഈസ് ദ എനർജി ഓഫ് പാരന്റ് ന്യൂക്ലിയ? എനർജി ഓഫ് പാരന്റ് ന്യൂക്ലിയ മീൻസ് വാട്ട്? Energy of parent nuclei is mv square, correct? But here this v is equal to 0 because question is given it is at rest, correct? Is rest and decays into two particles. So this is the two daughter nucleus. So these two daughter nuclei are moving with a certain kinetic energy. Okay, from where this got this extra energy? Because of mass defect. Mass is converted into energy. So this can be equated to delta m c square, because this is the energy which is converted as kinetic energy. Okay, so m by 2, so half into m by 2 plus m by 2 into 2 into m by 2 m by 2 v square equal to delta m c square. 2 cancel, 2 cancel. So what we need to be find out? Speed. So how to get the speed? V. So v square by 2 equal to delta m c square, correct? V square by 2 equal to delta m c square divided by capital M. So v is equal to, how much will come? V equal to root of 2 delta m c square divided by capital M. Now c can be taken outside. So c into, option B is the right answer. This is parent nuclei, not rest. These രണ്ട് daughter nuclei are moving. Daughter nuclei got kinetic energy, or they got kinetic energy from where? The mass defect. അതുകൊണ്ടാണ് this is equated to mass defect. correct? Then the value of v in the value v is equal to root of 2m delta m c square divided by m. C square root in earth. So what we will get? V is c into root 2 delta m divided by capital M. This is option B. We'll move to the next question, right? Question number 34. Which one of the following pairs of nuclei are isotones? Isotones means what? Same number of neutrons. So which one will have the same number of neutrons? A. A 74 minus 34. How much? 40. Gallium case 71 31. So in case 71 minus 31. Answer is 40. So answer A is an example of isotone. 35. A nucleus rupturing into two nuclear parts which have their velocities 2:1. What is the ratio of their nuclear size? A nucleus rupturing into two nuclear parts which have their velocities are in the ratio 2:1. So I told momentum is conservation, right? Momentum is conserved. So a nucleus which is rupturing into two parts, because initially I have one, this is splitted into two parts. This momentum is equal to, initial momentum is equal to 0. Final momentum, two things will be there. Final momentum of 1 and final momentum of 2. Final momentum of 1 plus final momentum of 2 is equal to 0. Then what else? From there we have to start. So velocity ratios are given. We need to find out what? Radius. Okay. So I'm writing 0 equal to m1 v1 plus m2 v2. So I can say m1 v1 size will not be negative. Modulus m2 v2. So v1 by v2 is equal to m2 by m1. v1 by v2 is 1. So m2 by m1 is 1 by 2. 1 by 2, 2 by 1. Huh? 2 by 1. It is 2 by 1. 2 by 1. Mass in the relation. What they're asking? What will be the size of nucleus? So how mass is connected with the radius? Density into volume. Okay, density into volume is equal to density into volume of 2, volume of 1 is equal to 2 by 1. Okay, mass is connected with. So what is the volume? Density will be cancelled. Okay, volume is 4 by 3 pi into R1 R2 cube divided by 4 by 3 pi into R1 cube. 4 by 3 pi, 4 by 3 pi cancels. Okay, so I got R2 divided by R1 equal to 2 raised to 1 by 3. Raised to 1 by 3 is to 1. So option A is the right answer. Velocity in the mass we find out radius. That's what we have done here. Nucleus which have their velocities are in the ratio. We want to what will be the ratio? Nucleus in the reverse R1 by R2. Correct? V1 by V2 is given, so we have to find out R1 by R2. Then reverse 1 by 2 raised to 1 by 3. So what is matching with that? Option B is the right answer. 36. A nucleus of uranium decays into nuclei of thorium and helium. Then 4 options. Helium nucleus has less momentum than the thorium nucleus. Helium nucleus has more momentum than thorium nucleus. Momentums are always equal. All momentums are equal. Helium nucleus has less kinetic energy and thorium. So what is the kinetic energy equations? P square, momentum equal ആണ്. So kinetic energy is equal to kinetic energy of alpha is equal to momentum same ആണ്. P square divided by 2m alpha. Kinetic energy of thorium Th is equal to P square divided by 2m Th. M alpha or mth is higher. Th, thorium 236 or something like that. So thorium, this is higher. So kinetic energy is lesser. So this m alpha is lesser, so kinetic energy is higher. So kinetic energy of alpha is higher than, or helium is higher than the kinetic energy of thorium. Answer is D, 36D. You can do, right? Can you do 37? Radius of aluminum 27 is taken to be RAL. Then the radius of 125 telluria is how much? Option A. Everybody done? RAL is equal to R into A power 1 by 3. So 27 raised to 1 by 3, equation number 1. And R for TE is equal to R0 into 125 raised to 1 by 3, equation 2. Dividing both equations, RAL divided by RTE is equal to R0 cancel, 3 by 5. So RAL equal to RTE into 3 by 5, or RTE equal to 5 by 3 times of RAL, option A. This is simple, right? The previously we done the same question, exact dicta copy. There it is 64, here it is instead of it's a 125. Okay, 38. If the radius of M and MP represent the mass of neutron and proton respectively. If an element having atomic mass M and N neutrons and Z proton, then the correct relation is A. M less than N Mn plus Z MP. The difference is called mass defects. So 38, answer A. 39. After 300 days, activity of a radioactive sample is 5000 dps, disintegrations per second. Activity become 2500 dps in another 150 days, which means 5000 to 2500. It is taken 150 days, which means half life is equal to 150. So T half is equal to 150 days. Okay, initial activity, suppose initial, okay, Excel and the 5000 I. So we have to go back. If I am taking one half life back, then what is its count? Backload 10,000 or half life. So one half life is 150 days. So question is given 300 days. After 300 days only it is 5000. So 300 days I am taking back. If I am taking first 150 days back, means it become 10,000. Another 150 days if I am taking it back become 20,000. So initial count become 20,000. 20,000 the first 150 came 10, next 150 came 5, the next 150 came 2,500. So backload, back trace edu. Okay, so after 300 days it become 5,000, half life. So one half life backload edutana nere double avum, one half life inde backload edutana one time double, so it become two time double. Correct? Two time double means 2, it become 10,000, become 20,000. So answer is equal to 20,000, option A. Half-life of, this is finished, huh? This is simple only, right? You understand, backload edukanam, half life, 300 days varadukku munnadi. What is the count? 20,000. Okay, 40. Half-life of radium is about 1,600 years. So half-life is 1,600 years. Of 100 gram of radium existing now, 25 grams will remains unchanged after. So 100 now 100 remains, 100 gram of radium remains now. So 100 in the 50 adukku one half life, 50 in the next 25 gram adukku next half life. So here one half life, here one half life. Here how much will come? So 100 to initial 100, ipo balance avlo 25. So how much is lost? 75 lost. So question is giving, look at the question, 25 gram will remains unchanged, means now 25 gram. So to become 25 gram, how many half life taken? 1, 2 half life. So 2 into 1 half life is how much? 1,600. So it become 3,200. 40 answer is D. Electron cannot exist inside the nucleus because, answer B, and de Broglie wavelength associated with the electron beta decay is much greater than the size of the nucleus. This mainly you are learning dual nature of matter and radiations. There we are learning why matter is called a wave nature. Okay, once you see the video you will understand dual nature of matter and radiation chapter. So dual nature means what? Two nature of light and two nature of matter. Matter means any particles. Correct? Any particle means electron, neutron, proton. So that already we know it is called particle. Why it is called a wavelength? Because the reason is the de Broglie wavelength associated with the electron in beta decay is much greater than the size of nucleus ne compare பண்ணும்போது adinde wavelength அதிகமாயிருக்கும், electron wavelength அதிகம் தான். Okay, that's why we call it as neutron is called it as, sorry, this particle is called it as wavelength. I'll give you a hint. For example, lambda is equal to h by momentum or h divided by mv. This we are learning, right? This we are learning. So lambda is wavelength. Wavelength is associated with which one? Wave nature or particle nature? Wave nature. Wave will have wave lambda. Particle have no lambda, right? Wavelength is the property of a wave. So if something is having wavelength means that is showing wave nature. Okay. Now the mass of here, mass of electron is how much? 9.1 into 10 power minus 31 kilogram. Mass is very less. Mass is very less. The lambda is very high, which means electron is showing highest wavelength. Highest wavelength means electron is behaving as a wave nature. Electron will have a wave character also. That wavelength is called, this wavelength is called de Broglie wavelength. Okay, so de Broglie states that particles like electron, neutron, proton, all these particles will have wave nature because their mass is less Lambda is high. If a particle having highest lambda means it is showing what nature? Wave nature. That's what. Now if you read the question, de Broglie wavelength associated with electron in beta decay is much greater than the size of the nucleus. Size of the nucleus means in terms of Fermi meter, I told, right? Radius is how much? 10 power minus 15. Here how much will come? The wavelength. 10 power 31 will go to numerator. Here 3 into 10 power 18 will be, so 3 into 10 power 8 will be there. All this together is the highest number. So lambda is very higher. So 41 answer is B. Okay, that was the question on nothing else. Question number 42. Okay, question number 42. If the total binding energy of 1H2, 2He4 iron and uranium nucleus are 2, and values are given, identify the most stable nucleus in the following is iron 56. 42A, iron 56 is the most stable. Suppose if iron is not given, then the next most stable is which one? How to find out? Neutron by proton ratio is equal to 1. Then that is the most stable element, right? We told N by P. N by P 1 are most stable. So N by P you have to find out. In this case iron is the most stable. We know from the binding energy plot itself. So 42 answer A. 43. Second last question. Third last question. At a specific instant, emission of radioactive compound is deflected in magnetic field. Compound cannot emit neutron because neutron is chargeless. Charge is deflection. Electric field or magnetic fields. So 43 answer D. 44. A nuclear reaction is given. Represent which decay? Beta decay. Specifically what decay? Beta minus decay. 45. Can you do this one? This is already we have done, right? How much you are getting?
1 by 7.
All of you done 1 by 7 lambda. Idhe mari two questions already we done. Same model, but different values. Same way. 1 by 7 lambda, right? Same questions we have done. Where and all? Question number 18. One is question number 18. Another is question number 25. Then 45. Different values. Don't just write 1 by 7 lambda. Solve it and write. Solve it and write.